In this video, I'm going to talk about the absorption of phosphate. So phosphate is a polyatomic ion. So it's one that has a phosphorus, then it has these four oxygens bound to it. And these oxygens usually have some sort of counter ion. So things like so hydrogen or sodium, and they can have different ratios of these hydrogens, sodiums, and sometimes potassiums, but we will be thinking mostly in terms of hydrogens and sodiums here. So that's why I put this R3 here as just kind of a generic. It can be some sort of positively charged counter ion. But anyway, so there are two main ways that phosphate rather enter or gets absorbed through the intestine. And so the main one is the paracellular pathway. And so that is essentially just moving between the cells, so just passively diffusing between the cells. And then there is the transcellular pathway, which uses this sodium phosphate symporter here. So using the sodium concentration gradient, where sodium is higher concentration in the intestinal lumen and lower concentration in the cell. And so the sodium is going to want to move down into the cell. And so using the energy of that sodium concentration gradient, it moves the phosphate into the cell. And so then we see that there is this just says a basolateral transport. And so I looked all over for what the actual transporter is in the basolateral part of the cell. And it seems like all the papers I found would just say that they don't know. So they would just put these question marks like this here. So apparently, it's still not yet known what this basolateral transporter is. But this figure here is essentially just the same as this one up there. So we're looking at this sodium phosphate 2B transporter here, which brings in two sodiums and one phosphate here into the cell. But I also wanted to show that this vitamin D actually increases the transport of phosphate into the cell. And that makes sense because one of the main things that phosphate is used for in the human body is for constructing bones. And it's that's also what calcium is obviously known for. And so the bone matrix is made up of these calcium phosphates. And so phosphate is needed for bone health. But for various reasons, we don't like to take phosphate as like a supplement and stuff like that because having too much phosphate can cause different disorders. I think it's called hyperphosphatemia or something like that. And you actually see that a lot with people who have like chronic kidney disease. And so that's why it's not really recommended to take phosphate supplements or try to get like a high phosphate diet or anything like that. All right, so here we are looking at, so we have a normal high phosphate diet here, and so we are bringing in the phosphate through this sodium phosphate transporter. Once again, the basolateral transporter is just a question mark, but we see we have this paracellular pathway here and the thick dotted line showing that there is a lot of sodium or phosphate rather coming in that way, whereas in low phosphate we have these smaller dotted lines because less is going in that way, and so we actually have an upregulation of these sodium phosphate 2B transporters here, and we see that the with this sodium potassium transporter maintains that low concentration of sodium inside the cell so that so that this can actually be going down the gradient and helping to bring the phosphate into the cell. So here we have these two different kinds of inhibitors. So this sevelamer is actually binding to phosphate out here in the intestinal lumen. So it's sort of binding phosphate and not allowing it to move into the cell. So we can see it's not moving in through the paracellular, and so that is simulating a low phosphate concentration. So we see an upregulation of this transporter here. If we look at this molecule here, tenepinor, so this shows it sort of inhibiting the paracellular pathway. So over here, what it's actually doing is inhibiting this sodium hydrogen exchanger here, so this NHE3, and so it's further reducing the sodium concentration inside the cell, and so that's actually sort of increasing the gradient of sodium here. And so these sodiums here are going to want to sort of move into the cell even more, which is going to sort of speed up this transporter here. And so that's actually going to cause an increase in the phosphate concentration inside the cell. And so this transporter will actually be down-regulated from that. So that's what the tenepinor does. Yeah, those are two inhibitors of the sodium moving into the cell. So yeah, like I said, here we have the tenepinor. It's inhibiting this NHE3, which is inhibiting the uptake of sodium into the cell, and so it's actually going to inhibit the sodium phosphate 2B transporter. So down here, this is just looking at chronic kidney disease, which I mentioned above. And so we see that after postprandial, which is just kind of a fancy word for after eating. So we see that the serum levels of phosphate are relatively the same in both the healthy and the kidney disease. So healthy is the open circles there. In chronic kidney disease are these closed squares there. And so we see over here excretion of phosphate after the meal. We see that the healthy has sort of this increased excretion, where with the chronic kidney disease here, we actually have this constant higher excretion going on here, and so that can affect the phosphate levels in the human body. I think I said above that the chronic kidney disease causes hyperphosphatemia, but I think it was actually the opposite. It causes hypophosphatemia, because we see that that somebody with chronic kidney disease is constantly excreting phosphate, and so they're going to end up with hypophosphatemia. But yeah, anyway, the take-home message here, so phosphate, like I said, the primary pathway to be taken into the human body from the intestine is this paracellular pathway, but then we also have this transcellular pathway, which is somewhat more it's a somewhat more regulated pathway, which can sort of help regulate whether we have these high or low phosphate diets here. But anyway, I hope you found this video helpful, and I will see you in the next one.